However, there is good news too. We have just learned that two different functions can have the same derivative. And in fact, not just two, but infinitely many functions can have the same derivative. All I gotta be doing, if I want to be a jerk about it, is I just have to choose some constant, and I've got infinitely many numbers I can pick from. All of those different functions will have the same derivative. The good news is that's the only way that two functions can have the same derivative. So what do I mean by that? If two different functions have the same derivative, then one of them must be equal to the other of them plus some constant. Another way to think about this is if I took my f of x that I thought undoes the derivative, and I take your g of x that you thought undoes the derivative, how far off are we from each other? The difference is just going to be some fixed constant. So to put this more practically, you could imagine that I've got some function whose derivative I know. Let's say the derivative is f prime of x equals 2. I look at that and I think that the original function must have been 2 times x. What other functions have the same derivatives as this? Well, 2 times x plus 1, 2 times x plus a half, 2 times x minus 3/7. Yes, sure, all of those have the same derivative. That's the only way that a function can have the same derivative. Well, that's a pretty big claim. Two different functions have the same derivative. They can only differ by a constant. Why should that be? I'm skeptical. Let's think about it. A derivative has so much information about what the graph of a function looks like. The derivative tells me where the function increases and where the function decreases. And for that, I could even do the first derivative test. I can find my local extremes. I could find my maximums and I can find my minimums. If two different functions have the very same derivative, well, that would mean that they've got to be increasing in the same places. They've got to be decreasing in the same places. Okay. Well, if they have the same derivative, then they've got to have the same second derivative too, as long as they are functions that we can take two derivatives of. Not all of them are. Okay, so that means they've got the same concavity everywhere, right? Second derivative tells us where the function is concave up, where the function is concave down, and so on. So my two different functions will have almost the same graph. All those most important features will still be the same on these things, except one will be shifted up above the other one slightly, or maybe pushed down below the other one. Here I have two different functions, f of x and g of x. How do I know they have the same derivative? Both of these functions have the derivative 2 times x minus x of x. And here I've been a little cheeky I'm using the fact that exp of x is just another name for the exponential function. Okay, so they both have this same derivative. It means they have the same concavity everywhere, right? They're both concave up at this same x coordinate. They're both concave down over here at x equals 2. In fact, that's true for all of these different functions. I'm just sliding this graph up and down. That doesn't change the derivative. That doesn't change whether the function is increasing or decreasing. That doesn't change whether the function is concave up or concave down. In fact, if I know that derivative, if I know everywhere the function is increasing or is decreasing, then I completely know what the shape of that graph should look like, except I'm missing one piece of information. I don't know the y-intercept.